Alright, in today's class I'll be talking about projectile motion. I'll be summarizing projectile motion. I know you've heard your teacher say projectile motion is the motion of a body through a parabolic path, or the motion of a body through a curve. They will now come and draw something like this. It's okay. But as a physicist, I want you to see projectile motion as kinematics in 2-dimension. I also want you to see it as 2-dimensional motion under the influence of gravity. So whenever we're talking about projectile motion, we must be checking if gravity is there. Gravity must be there. But if it's on the x-axis, no gravity. 0, no gravity. But on the vertical component, there must be presence of gravity. So what it means is that projectile motion is that type of motion that deals with x and y-axis. But it all happens at a particular time. So when an object, for example, is launched this way, as it's going up, see that it's having vertical axis going up. Now notice that on this horizontal side, it has covered some distance from this point to this point. Now notice when it comes down, you see, it's covering horizontal distance this way, and it's still covering vertical distance. So we say that projectile motion is the 2-dimensional motion. By 2-dimensional motion, we mean the x and the y, the x and the y axis. Now you know that we normally say u for initial velocity. So on the x-axis, we'll consider the x component to be u cos theta, and the vertical component to be u sin theta. Check my first video on projectile motion to see how we derive that. Alright, what I just want to treat here today is that under projectile motion, whenever it's projectile motion, there are cases or things you need to be looking out for. You need to be checking whatever you are giving. You need to be checking for maximum height. If he has maximum height, that is the first thing. You need to be checking for time to reach maximum height, which is t. Time to reach max height. And I know sometimes you have a formula in your head for it, but you just need to calm down for now. Then number 3 is total time of flight, time of flight. Then number 4 is horizontal, or you say range. So maximum height is the highest vertical distance. The highest vertical distance is maximum height. Time to reach maximum height is time for it to move from any point of rest, or should I say from the starting point to the highest vertical distance. While time of flight is the time for it to reach the highest vertical distance and return back to the ground or to its rest level. While range is the total horizontal distance covered before hitting the ground. Alright, with that said, so I've talked about parameters to note. So I know sometimes they tell you something about trajectory, angle, and the rest, but I'm just trying to focus on the key important things and to make the video as short as possible. So the next thing you need to know is that there are 6 cases of projectile motion. So there are 6 major cases. So 6 major cases of projectile motion. So the first case is the normal projectile, you know, which we say that it is the case where an object is launched from the ground level and it returns back to the same ground level. So you see, this is the horizontal distance covered. Let's say this is A, let's say this is B, and notice that it went up. This is the highest vertical distance, Shebi, so it went up as well. So that's why we call it 2-dimensional motion. So you now see that in this type of projectile motion, this is where you use all those your formulas like h equals to u square sine square theta over 2g. This is also where you do something like t, time to reach maximum height, that is from A now to C, to be u sine theta over g. Then total time of flight is the time for it to go this way and time for it to come this way, because they are on the same level. Are you seeing it? Half, half. So you just do 2u sine theta over g. Now the range, if you remember, range is ut. And if you check my first video, you see how we did it to get u square sine 2 theta over g. Very simple. It's sweet. Case 1. Most of you've crammed it. Now, but case 2 is a case where, for example, an object is launched from a height. So you can be using your pen to write it down. An object is launched from a height horizontally. Then it comes down. So you see it. So let's say this is the height that the object is launched. Let's say you are the ones, should I say, this is your hand, and from here you throw a stone. You throw a stone, and this stone moves horizontally before coming down, and it comes to the ground. Okay, let's say this is the ground. So this is a second case, case 2 projectile. Case 2 projectile. So you see that here the maximum height is simply the given height. Given height. That's the maximum height. Given height. That's the maximum height. So h equals to given height. While the time t here, that is the total time of flight in this case, is simply, you see that there is no time for it to go up to reach vertical height. So the time is starting from here, is the same time. So the time here is simply equals to t as well. So there's nothing like time to reach vertical height. Rather, it's time for it to cover the movement, which is moving from horizontal and then coming down. And this is simply given by saying t equals to, we get it by using s equals to ut plus half gt square. This is an equation of motion for displacement. So since there is a height, notice that there is a height here. We'll call this height h equals to. Now, since there is coming down, anything coming down in physics, once you are coming down, once an object is coming down, your initial velocity is 0. Once it's coming down, so u will be 0 times t. Everything here will be 0. Now, because it's coming down, gravity is being obeyed, so it will remain plus. If not, it would have become minus, which will affect this. So it remains plus. So plus gt squared. These two can go under. So you see that you have h equals to gt squared. Everything here is 0 from here over 2. So anything standing on this over 1 cross multiply. You have 2h equals to gt squared. Divide both sides by g to get the time, so that you get t squared equals to 2h over g. Then t, take the square root of both sides, so that t, which is equals to the sin t, is equals to square root of 2h over g. Hope you know that when square cross equality sign, it becomes square root. So that is why I said that in this case, what you just have as your total time of flight is simply roots 2h over g. That is how you get it. So for this case too, that is how you do it. Now the range here in this kind of question, this type of question, the range will simply be, notice, that time that you launch this thing, there will be a height from, that is, you know what velocity is now? Movement, change in direction. So as you launch this projectile, as it's moving, it's definitely moving with a velocity. So that velocity is moving with, and then the total horizontal distance that it will cover, because that is what range is. Range is simply horizontal displacement. And you remember, for example, if you have v is equals to s over t, this is what we call range. So you see that, and this is u. So when you cross multiply, you have that r is equals to ut. So in this case, what you just have is ut. Whatever you are given, initial velocity you are given, times time, and the time you have here is this 2 root 2h. So r here will simply be u times root 2h over g. So that is for case 2. That is how you do case 2. And whatever you get will be in meter. And whatever you get here will be in seconds. Remember that unit of time is second. So it's always important to remember your units. So now let's go to case 3. Let's go to case 3. So for case 3, projectile motion. Case 3 is a situation whereby an object is projected. You can be writing down, making a note of it, but I don't want to start writing the English I'm speaking here. So a case where an object is projected from a height at an angle, then it returns to the ground level. So notice, let's say this is a ball projected here. So in case where a ball is projected from a height at an angle, notice that it's not like the second case where you just move straight. So this is case 3. So let's say there's an angle here, projectile angle, trajectory angle, which is theta. So you will notice quickly you notice that this case 3, everything up here is looking like our case 1. That is everything here. So it's looking as if, see what it's looking as? It's looking as if you have something of this nature up here, which is case 1, moving from ground level to ground level. But notice, then come down, then there's a height here. Is it not true? So that is what you're saying. So you need to know this. So for this case, for this type of case, to find the hedge will simply be everything here. Whenever I have this case, which is case 1, hedge is u squared sine square theta all over 2g plus, there's a height given here. Notice that there's a height given here. That is in this motion. There's a height given here which runs this way if you check and coming down. So everything from this point down is different from what you have up here. So plus giving height. Plus giving height. Notice that when they tell you a body is projected from a cliff, they will always tell you the height of the cliff. Is it not true? Yes, it's true. So this type of case, for you to find the maximum height is simply u squared sine squared theta all over 2g plus whatever height you are given. That is how to find the maximum height here. Now for time of flight or time to reach maximum height, see, you see that from this point to this point, let's say this is A, let's say this is B, then let's say this is C. So time to reach maximum height will simply be time from A to B, which is A to B. Then, and you know that is the sentence saying u sine theta over g. Yes. So I'm trying to be as fast as possible. Now, why the total time will be, total time or time of flight will be time to reach A to B, and then time from B to C. So, which is the sentence saying u sine theta over g. Time to reach maximum height plus time to move from maximum height to ground level. That is B to C. Time to move from maximum height to ground level. And this is given by, notice that everything here to this ground level, everything here is the total height. Total height. So it simply means that what you will do here is to remember that anytime you want to find time, you always use that S equals to ut plus half gt square, and this becomes h because it's vertical. So in projectile motion, always be thinking of the vertical side whenever you're talking about the motion. Then when you want to talk about range, you now think about the horizontal side. So from these points to coming down, u will be 0 times t, everything here will be 0. So you see that because it's coming down, your g will be positive, so plus half gt square, which is the sentence saying crossover 2h equals to gt square. And making t subject of the formula, this will cancel. Then take square root of both sides so that you have t equals to root 2h over g. And the t here is capital. Okay, sorry, the t here is still small. Let's use small t because the total time is what we are using. So whatever we have here, this t is this one for time from B to C. Time from B to C. So let's replace it, which means that in this type of case, and you remember that your hedge here is simply this, everything here. That is whatever you get for your maximum height, because it's from here to here. So we simply say that this type of case will be u sine theta over g plus root 2h over g. So that is how you get your total time of flight in this case. What about your range? Your range will simply be equals to u t. And you know that since there's an angle here, u is not just u is a component, so u cos theta times, and t, your total time of flight is everything here. So it's going to be u cos theta times u sine theta for g times root 2h over g. That is going to be your range. All right, let's move to case 4. Case 4 is where you have a body launched from the ground level. For example, you kick a ball at an angle. The ball now fly up, then come to the zinc of your landlord and stop. And you know you cannot go up with ladder to climb it and bring the ball down because there will be trouble. So you see that this is a case. So notice that everything up here is also looking like your case 1, projectile motion. It's looking as if what you have here is simply, you have moving from ground level, then you now have the heights. Then you see, we have extra now. And this extra that is moving from ground level is in the same height with what you have here. So it's a case 2 projectile motion. So how do you find the heights here? The height will simply be the same way you do for the case 1. That is, the height in this case 4 will be simply, maximum height will simply be the same thing as u square sine square theta. You know sine square theta is the same as saying sine theta square all over 2g plus given heights. That is how you find the maximum height. Now, how do you find the time? Total time. You will first of all find the time to reach maximum height. So it's simply, if this is A to B, then C. So to find the time, you know that T first of all will be equals to U sine theta, time to reach maximum height, all over 2g. All over g, see 2g, are you okay? All over g. Now, that is from A to B. Now, for you to get, there's also another time here, that is time from B to C. B to C. And time from B to C will simply be using S. Whenever we use S equals to UT plus half GT squared, you will notice that if it gets to be the maximum height, it will start coming down. And as it's coming down, U will be 0. And because it's coming down, G will be plus. So if you do it very well, you see that S, because its height, it's going through a height to come here, this height, S will become h. So if you do it very well, you will still see that you have half, or you say GT squared over 2, which will still give you 2h over, 2 over G, then T squared, then which is the same thing as saying roots. If you like, don't remember. This is the same thing that we did. Whenever you solve this to make T such a formula, you have that T will simply be equals to root 2h over G. But the only difference now is that the h we are going to use is simply the h from U square sine square theta over 2g. That is time, that is maximum height, because notice that the height here is the same height with that your normal case 1. The height here, yes. So the height, because what we are considering is the time from B to C, and B to C simply happened that the height up here, it didn't cover this one. So that is the hedge you will put here. Then times it with 2, divide it by G, take the square root. That is your T here. So that by the time you do it, you now come and combine what you have here, which is going to be that the total time of flight will simply be U sine theta over G plus root 2h over G. It is the same formula. It is the same formula for case 3, sorry. But the only difference is that the hedge you are using here, is the hedge from U square sine square theta over G. That is the answer you get for the hedge for this. That is what you are using here. Remember what I taught you here. Alright, so the last 5, the 5th and the 6th one is simply when an object is thrown up and when an object is played horizontally. So in this case, what you just do is that instead of U square sine theta for the vertical, you know that's U square sine square theta all over 2g. So instead of, because there is no angle when it's going up like this, so you simply use maximum height to be U square over 2g. The same thing in this case. So, and there's no height here, there will be no g. So when it's horizontal like this, you just use your kinematics equation. What is your normal kinematics equation? That is what you use here. So I'll still make a video in case 5 and case 6. Why range in this case will simply be U square over G. You remember that range is u squared sine 2 theta. So it will simply be this. So subscribe, share, ask your comments, your questions in the comment section. Thank you.